again. So now we have another talk, surprisingly, from Arnaud Ferraris about Debian on mobile phones.
Well, thank you, everyone. I'm hoping that this will be more of an open discussion rather than just me presenting. So I hope I can be lazy and just let you do a bunch of the talking. Basically, I'll still start by introducing a few things about how Debian can be used already on some mobile devices, which are basically tablets and smartphones. And from there, I'll introduce what I think are the current pain points and what I think should be improved with a few ideas, and hopefully I'll get your comments and suggestions, maybe objections, if any. But first, I've been involved in Debian for only a few years, so you probably don't know me already. I've been a user for a very long time, but actually only became a Debian developer in 2022. And the thing is, for many, many years, I've been frustrated by the lack of hackability of basically what we used to call smartphones. And so, basically when COVID started, I wanted to work on that, and there were a few devices available. So I initiated a Mobian project, which basically is a Debian derivative aimed at mobile devices. And it led me to contribute to Debian as part of the DebianOnMobile team, and eventually ended up being a Debian developer. I also contribute small parts to the Rust and GNOME teams, but mainly involved in the DebianOnMobile team itself. So what's the current state of Debian on mobile devices? First, we have a few Linux-first smartphones which are available right now, and tablets as well. You probably heard about the PinePhone, PinePhone Pro, and the PineTab, as well as the PineTab 2, PineTab V from Pine64. There's the Librem 5 by Purism, which are all meant to run a Linux, normal Linux and operating system, not Android. And there are also a few community ports of Qualcomm-based devices, mainly on the mainline kernel. So these are basically devices based on the Snapdragon 845, mainly the OnePlus 6 and the Pocophone F1, but a few other have been worked on. And there's also some interesting work in progress at Fairphone on the 3 latest phones they released. Actually, the Fairphone 5 is really promising because it uses a Snapdragon chip based on the chip which is used on several Chromebooks. So the SoC is pretty much supported upstream, and there are just a few adjustments to be made for the Fairphone 5. So this is potentially a good target for Linux on mobile in the future. So here are a few of those devices. I'm assuming you have seen them before, but We also have a few graphical environments which are targeting mobile devices, and we can't use XFCE, GNOME, or KDE, at least not the normal desktop environments on mobile devices, because we have tiny touch screens, no keyboard, no mouse. So there are a few projects based on either the GNOME ecosystem, the KDE ecosystem with Plasma Mobile, and some completely different stuff like SXMO, which is more based on Sway, which exist. They are packaged in Debian, and it's all managed by the DebianOnMobile team. So we have those graphical environments already available. We also package and maintain the essential middleware like Modem Manager, MMSD, which is a user space daemon for handling MMS messages, which require quite a different kind of processing than SMS. We also work on adaptive applications, which are basically apps that you can run on your desktop system and use it, be quite comfortable, and it will use all the screen estate you have available. But you can also shrink them to a mobile display, and it will just work as well. So those are packaged usually within the relevant team. For example, no apps which are adaptive are packaged within the GNOME team, and so on. So from a user space perspective and a really high-level perspective, things are going on quite well, and basically all the user-facing applications and bits are there already and work quite fine. There's also a separate team, which is the Mobian team, which works on enabling device supports and providing images for specific devices to run Debian, or at least Mobian, on those. So what's Mobian? It's a Debian derivative and also a Debian team, which basically is a subset of the DebianOnMobile team. We all work in all the Mobian developers also work as part of the DebianOnMobile team, and we maintain roughly, well, actually it's exactly 35 source packages as of now. A third of those is basically kernel packages with lots of downstream patches between 100 to 300 for each device or each device family. This is our main issue right now. We have another third, which are device-specific packages, basically some meta packages, pulling in the right dependencies, and also configuration tweaks we need to have per device. I'll talk more about that later. The rest of the downstream Mobian packages are basically not fit for Debian yet, because either they're low-quality software and pretty much nasty hacks, just trying to address one specific use case, but not to be used on the long term. Temporary forks with some patches to ease the use of applications of mobile devices, and downstream also forks of, for example, the kernels. And so Mobian is there to have some broader device support and not just limited to what upstream Linux supports. And offer options for installing Debian and running Debian on devices which are not fully supported upstream. So from there, how do we get to full support into Debian? And I hope that's the part where you will be interacting a bit more. So the first problem, in my opinion, is device-specific tweaks management. There are lots of things which are handled upstream, thankfully, but there are still cases where we must have specific config files for each device that can be, for example, audio sample rate and format, because on the PinePhone you have the modem hooked up to a specific audio interface, the main codec hooked up to a different audio interface, and you have to basically make sure that the sample rates for both interfaces are multiple. So you need to have like 8 kilohertz on one side, 48 kilohertz on the other side, and that has to be enforced at the audio server level. So we need to have a configuration for that. Those can be also Udev rules related to downstream kernel patches. So nothing really standard at the moment, and things that might evolve when things are upstreamed and probably maybe use different names, different interfaces. So things that cannot go into Debian in their current states. And all sorts of other tweaks could be needed for PolyKit, for modem manager, for all sorts of parts. Currently, we handle that in Mobian with one binary and one source package for each device. So basically, we have PinePhone tweaks, we have PinePhone Pro tweaks, we have Librem 5 tweaks, and so on. That doesn't scale really well when you want to basically increase the number of devices you support, and that means that each time you want to support another device, you will have to add a new package to the repo. That's also a big step for contributors who would like to work on supporting other devices in Mobian. There's a package in Debian which is called Mobile Tweaks. It exists. It brings in only upstream-backed changes, and we went for the path of least resistance for that one. And every change which could be controversial is not included in that one. So we're missing a lot of changes which would be actually necessary to really use the devices. And Mobile Tweaks also generates one binary package per device supported. So that means every time we need to add a new device, that's a new binary package, that's a new round trip to the new queue also, and it just doesn't scale. So how could we solve this problem? I already worked on something similar for the Android devices. As you probably know, when you have a Qualcomm-based device, you need a lot of binary firmware to have it operate fully. The thing is, those binary firmware are shipped by the phone manufacturer, and there is no redistributor license attached to those. So we just can't import them into Debian and be like, okay, that's cool enough. Instead, what we're doing is we're using a package which is called DroidDrer. It uses several config files, one config file per device basically, and it's a boot time service executing on the first boot. It identifies the device it's running on through the device tree compatible string, fetches the corresponding config files, and then uses that config file to mount Android vendor partitions which are already present on the device, grab the binary firmware from there, and then put it into /lib/firmware/updates, and then triggers a rebuild of the initramfs, reboots, and that's it. You get your Android phone with all the firmware you need to use it under Linux. So basically, my idea about tweaks management would be to reuse kind of this approach, have one single binary package holding a bunch of different config files and config fragments and tweaks, and have it at runtime identify the device it's running on, dispatch all the config files and fragments to the relevant places, and then let the system finish its boot so it uses those config files. The thing is, with that approach, there would be lots of files which would be unknown to DPKG and untracked basically by the installer and all the package management tools. It would require also adding files to /etc, which would not be identified as conf files the way we know it. So should we keep those when we uninstall the service, or should we remove those, basically? And there probably are other concerns about that. So that's the part where you start talking, hopefully. If anyone has any opinion, ideas, suggestions on that, you'll be more than welcome.
Thank you. I think you've been implying an aspect that I would like to question. So when we use mobile phones, the typical way of installing and upgrading them is OS image updates, like replacing the entire operating system. And when you care about files unknown to depackage, that probably means you want a writable root file system that happens to be upgradable with standard apt depackage stack. How do you see these, let's say, competing models of managing systems be relevant to Mobian? Is it like preferring one way or the other? Do you see one being taken over?
Currently, the approach to the system update and installing software and so on is really to have a usual Debian system running on a phone. So yeah, it's just being updated through apt, and you can install new software that way. And the idea is to give users the ability to do exactly what they would do on a desktop computer, but on the mobile phones.
Okay, so I actually have answers to two of those things. So one was like something we're experimenting with on SteamOS, which is related to your thing, like the etc. thing is a real pain point for us. And one of the things we're looking at is for some packages, we just make the etc. Because it's on our immutable file system, normally immutable, a symlink to run. And then at boot time, we install the hardware-specific things into there. So by the time the rest of the system comes up, it's pointing at the correct config. It's not a 100% solution to the problems you discussed there, but it might help. And certainly it's allowed us to do things like allow possibility of future hardware variation without changing a single distributed operating system image. Going back to the other question, so SteamOS allows both. You can, normally you get atomic updates. You can run a small script which then basically undoes the immutability, allows you to install individual packages, play with your system as if it was a normal updatable system. And then if you screw up or hose your system, you can boot to the other slot, or you can undo that and just like redo the update and go back to where you were before. So you get kind of the best of both worlds.
And similarly on the etc. and /run thing, so Udev, for example, supports already loading rules from /run/udev. I mean, would one viable approach be just to extend that support to more places? Do you have a list of things that might need to be extended to not just monolithically load all of their information from /etc., but also to have some kind of parallel directory that could be modified at bit time?
Yeah, that's a sensible idea indeed. Actually, we've done that for the U-boot menu package a while ago, so that we could ship per distribution configuration for generating the U-boot, basically boot script, although it's not really that, but yeah, and we added the ability to use under user share and so stuff like that. So that could be a way to do to improve things, but yeah, it needs to change upstream software. Yeah.
So this is very interesting. I have a Fairphone 4. I'm running de-Googled AOSP on it. One of the things that is good about Android is one of the things I like about that is AOSP has they've put a lot of thought into protecting the system from apps. So they've got this concept of an app, which is rather different to a Debian package. Debian packages have a great deal of authority over the system. Certainly when you install them and when you run them, they have a great deal of authority over your account. AOSP apps don't have that, and the consequence of that is that you can be a lot... So I don't run non-free stuff apps on my phone, but I do download random stuff from F-Droid without thinking about it too hard. And, I know that F-Droid is not curated to the degree that Debian is, and there's an actual trade-off there. That gives me a wider availability of software which I can run with still some kind of reasonable degree of comfort. Why should we, and this is a bit of a tendentious question, why should we use the operating system that I use on my laptop which doesn't have those security features on a mobile phone where I'm more likely, for example, to want to install random things in the field when I don't have time to think about it hard, or I might even want to deal with proprietary software, stuff like that.
To be honest, that's really a personal question. The thing about app security, protecting the system from the apps, technically it's already possible with Linux, using Flatpak, for example, where apps are also isolated and only have access to limited parts of the system. At least that's the goal. And when the developers are really conscious about that, they really ensure their app has limited access. The thing is, for some extreme nerds like I am, I do want to use the same operating systems on all the machines I use daily. That means my desktop, my laptop, and my mobile phones as well. I don't expect everyone to have the same will or needs, but I think that's a choice we should offer, and that's pretty much the point of Mobian and similar Linux distributions right now.
Okay, cool. That's a good answer. There's also obviously advantages in using the same thing. Your answer about Flatpaks is interesting. One of the things that I like about the way I manage my mobile phone that I find more uncomfortable, my laptop is far too powerful. I can't randomly install stuff on my laptop because that's too much of a security problem. But on my phone, I have access to a wider range of software. Are we expecting or intending that there will be, random Flatpaks for stuff, and that we'll install Flatpaks in a similar way to the way that I might install apps on my phone, and in the way that I don't allow myself to install random software on my laptop? Good. Say that again into the mic.
So the goal of Flatpak, and I think also Snap, although I know less about that, is that they are the free software world's answer to the Android app ecosystem. At the moment, we have a bit of a chicken and egg problem because the way they start populating their repositories is with existing Linux software, which has not been written with sandboxing in mind, and those apps require powerful features that you don't want random untrusted app to have access to. Sometimes because they were written just blindly assuming they could do things system-wide, and sometimes because the mechanism to do that in a ask permission first Android-like way doesn't exist yet. The goal is that over time, Flatpak apps with extremely powerful permissions will become less and less common, and will become more and more red flagged by app stores. So you can see this in GNOME software, for instance, certainly in Unstable. If you're browsing through Flatpak apps in GNOME software, there is a color-coded indicator of the permissions of this app are safe-ish versus the permissions of this app are scary. And the intention, I believe, is to use that as a mechanism to nudge developers towards not requesting powerful permissions over time, and get from things are unsafe except when they're safe to the other way around. That apps with the ability to do sandbox escapes become a thing that you'll get asked, are you really sure about this? This is dangerous and powerful. And some apps will always have to be that because they cannot work any other way. In the same way that some F-Droid apps are flagged in their description as this needs root and will only work on a rooted phone. I think there have also been efforts to. I'm not involved in any of them, but I think there have been efforts to make it possible to run Android apps on a free world, as it were, phone, using either a VM or some kind of container technology, by providing the APIs of Android or a big enough subset that in practice many apps work. So instead of the Flatpak runtimes and APIs, which are very much free desktop flavored, providing Android flavored APIs in parallel. So same hardware, different interface.
Yeah. There's actually a project which is called WaitDroid, which basically runs an Android user space inside an LXC container, and you can from there install and run Android apps on a pure Linux system. Any other comments on this part of Twix management and so on?
I suppose quite naively, why can't you just make Debs on the device to contain these things that you're worried about not being tracked?
What do you mean? I'm sorry.
So you're saying, okay, you're going to download or put together a bunch of configs, and then you want to put them in etc, but those are then not marked as conf files, so it's a bit of a pain. Why not make a Deb?
Yeah, well, the thing is, I think making a Deb, it's not about downloading the config. It's really about how to package those tweaks into Debian in a way that is both scalable to add support for multiple devices and that does not do anything harmful to the system. And the thing is, having one Deb, having it as a Deb package, as long as it's one Deb per device type, that doesn't scale, because every time you want to add support for a new device, you have to introduce a new package. And the ideal end goal would be to have hundreds of devices supported with this kind of system. And yeah, I don't see having hundreds of binary packages, each tied to a very specific device, which is why I'm thinking about the approach of having one single Deb package which holds all the possible config tweaks for all the supported devices and use its own configuration format to know which files to dispatch where.
Right, but my point was more, you talked, for example, about the Droid juicer being at like a first boot, sets some stuff up, and then reboots, and then life is good. The stuff that it sets up, it could equally well literally construct a Deb on the fly and install that Deb. So why couldn't you just do that for your Deb that's on first boot? It's gone, okay, I'm on this kind of system. These are all the config files I need, and this is where they all need to go. Make a Deb, install it, and you're done.
Okay, I understand better, and that's actually a very interesting suggestion. I'll keep that in mind, definitely.
Suggestion may be very interesting for like debugging depending on version of Android firmware you have, and like you could then easily share this package with someone else and say like, can you test this, because maybe my firmware which is in a phone is a bit different than yours, because if it's extracted from the ROM it can be like slightly adjusted.
Yeah, there have actually been some discussions on the forum of Postmarket OS, which is kind of a similar project to Mobian, but using Alpine Linux as a base. And so apparently there is this one guy which tested every single Android ROM for the OnePlus 6 to check which one was working better in terms of modem support and voice calls quality and so on. So yeah, indeed having Deb packages constructed from that could be interesting to share and distribute this kind of load. Right. So yeah, thanks for your comments. We'll get to the next point then, which is hardware enablement. So yeah, as I mentioned, lots of downstream patches are needed for these devices. Upstreaming those is work in progress and it's taking a long time. But you have also, for most of those, basic support upstream. I mean, both the PinePhone Pro and the Librem 5 can at least boot, have some graphics environment set up, have touch input working. For some of those, the Wi-Fi could even work. The modem usually works. So there are lots of unsupported features, like the cameras and the USB-C display output, for example. Even the charging is not properly supported upstream. But you have at least basic functionality. And it would be nice to have at least some kind of basic support in Debian for those devices. There was some discussion last summer in 2022, I think, when one Purism developer opened a merge request for the kernel team in Debian to enable the relevant config options so that the Librem 5 could at least boot with the official ARM64 Debian kernel. There's been some pushback from the kernel team because basically it might not scale the same way. We don't want to have hundreds of new packages for hundreds of devices. Is enabling config options in the Debian kernel makes the kernel grow in size. And overall, if we add that for any random kind of ARM64 device, we'll end up with huge packages. And that will cause other issues to already well-supported platforms. So, yeah, my point here is we need to find a way to be able to have a Debian kernel working on some mobile devices, but maybe not stick to a single ARM64 kernel. I don't know if that could be an option for the kernel team to propose, to offer. Like in AMD64, we have the real-time kernel variant, we have the cloud variant. Maybe having an ARM64 mobile kernel in Debian would make sense. So I'm relying on you once again for comments and suggestions.
Your answer to Ian was actually what I was looking for earlier regarding use cases. So it's not as Boolean as it may seem, I think. So you can still customize OS image-based system if you use like Flatpak or Snap. And you can also customize it if you make the image creation easy enough, such that the local user can just roll their own image and then upgrade to that. I'm not sure whether such an approach solves your use case, but assuming that it would, an option is to generate ephemeral kernel packages just for the purpose of building the image, then bundling it all up, and then delivering that one image, which is also more close to how smartphones are operated these days, and provides benefits like we can do smaller kernel images, we can remove functionality out of packages that is not going to be exercised on particular devices. It enables a lot of optimizations that currently cannot be done and add to image sizes. So do you think that's something that would solve your way of using this?
I don't think so. That's an interesting use case and an interesting proposal, but the goal in the end would be to have one single kernel which would run on any device. And basically you have one image. In my view of the things, at least, you would have one image you could flash to basically any supported device. And then don't have to worry too much about having this specific kernel and so on.
One image, sorry.
Yeah, one kernel to rule them all, and
So let's get this right. One image for every supported device. So for each supported device, there's going to be an image effectively very, very quickly. But the one image to rule them all thing you were talking about, it's right until we get another mobile phone which has slightly different bits, so needs another image, and it's going to fork and fork and fork forever.
Probably, but it can be done to some extent, at least. For example, for the Snapdragon 845 devices we support, we have actually one single image for the root file system and only one boot image, which is specific to Android. For the only reason for that is that basically the device tree must be appended to the kernel, and only the device tree for that specific device. So we have to generate different boot images just for the sake of having this device tree corresponding to the running device. But otherwise, the kernel and initramfs are identical, and the rootfs is identical as well.
So again, with that, it's possible to have multiple device tree setups, providing you can identify what you're running on, or you can identify a specific device tree name to use. So you can then have a lot of different device tree files.
Yeah, but that's the Android bootloader, which is responsible for that. And for most of those devices, the bootloader is signed and cannot be replaced with any self-compiled binary.
Sounds like you need a shim.
Yeah, I don't know if it would help, but we have Linux source packages in the archive as a binary. So you could have a package depending on that and then do your stuff you want to do outside of involving Debian kernel team. And that you might, I don't know how good the scale that, but I mean, that's a start.
Yeah, that's an option. The only drawback being that effectively it doesn't scale for maintaining multiple streams of kernels, and it basically doesn't match the goal of basically dissolving Mobian into Debian at some point. The whole idea is to upstream everything we can and ensure we can use just pure Debian with no external repo for those devices. We're not there yet, but we're working towards that. And yeah.
So the idea of a separate kernel makes sense if the set of modules you need is reasonably disjoint, right? Is there a set of stuff for mobile phones which is kind of different for the set of stuff for desktop servers and laptops? If there isn't, it's probably not going to help very much, I think is basically the point. I don't know the answer to that question.
Yeah, there's a bit of both, actually. We have some kernel modules which are shared between the desktops, laptops, and mobile phones. One example would be the Wi-Fi drivers, which are basically the same chips used all across the board. But there are also some modules which would be very specific to one particular device. A good example for that would be display panels.
Yeah.
Every mobile device have a different display panel, or nearly every one, and each display panel needs its own module in the kernel. So yeah, that's one thing.
I guess
which is
the
very
phone
specific.
set of CPUs and cameras is going to overlap with the stuff we're about to get in the new laptops, so they might be very different. I don't know. I mean, the cloud version works because basically it can go, I don't care about hardware, so I'm not having any of that nonsense, so you can make a much smaller kernel.
Yeah.
So yeah, I mean, it's a good idea, but I'm not sure how much difference it's actually going to make in when we just end up with enormous kernels, and that's fine until it's all too big for everywhere.
Have you encountered the Flash kernel package?
I had a brief look.
I think it's more oriented towards dev boards and ASBox boxes, servers, that kind of thing. But you mentioned having to customize one of your kernel images by appending the device tree blob, so you could use a generic kernel, but you just had to append that one thing. And I think that is something that Flash kernel knows how to do for supported hardware. So it knows how to do things like, for this particular device at runtime on the end user system, I need to concatenate the kernel blob, the init ramphus, the device tree blob. And each of those things can be somewhat generic. It's just the sort of final composition of them that is specific to particular hardware, but that's basically cat. So you could do it very easily on the end user device or in the installer.
Yeah, indeed.
So that might be an alternative to having a million kernels.
Yeah, as long as we manage to have one single kernel working for multiple devices, which unfortunately we're a bit far from right now. I mean, having basic support with what's going on upstream is just fine. If we want to have full support, we have multiple kernels also, because there are some patches required for one device which conflict with patches required for another one. A good example for that is the DisplayPort output IP, which is, I think, from Synopsys and used in both the Rockchip 3399 and the IMX8M. And both works in different enough ways so that you can't have one single kernel being able to use this IP block on both kind of devices.
Yeah, I believe the Flash kernel answer to that is your device will not be supported until a generic kernel can work on it. And if it needs magic patches, go and talk to upstream and get that fixed.
Yeah, that's a separate process, which is not directly related to Debian, but we're hoping that in the end it all ends up in the upstream kernel and we don't have to worry anymore about that kind of stupid conflict. But you're right.
Why don't you just have a mini kernel which is specific to your device, and then you KSEC into a generic kernel that is going to be installed in the main partition? And your mini kernel, the only thing has to do is recognize your hardware and be able to load the secondary kernel, which that one is generic.
For now, I've tried a few things around that, but couldn't get kexec. I suppose that's how you would boot the secondary kernel. I couldn't get kexec to work with a different device tree from the one it was booted with. So it might be related to a specific SoC issue, or I haven't looked into details at that. But the thing is, for now, all of the things I've tried is once you boot a kernel with one specific device tree, you can't boot a secondary kernel with a different device tree. It has to be the same I don't know why exactly, and as I mentioned, I haven't looked into details, tried to debug that too much, but
that's what you want, no? You want your device tree to be on your boot partition, and you want to use that device tree to boot the main kernel.
That depends. The use case for now, for my experiments, was basically to have some bootloader on top of the Android bootloader on Qualcomm devices, and so have some kind of minimal kernel which would be able to then mount the file system and find the boot partition and the device tree, TrumFS and so on, and load those and kexec into this new kernel. The goal would be to have some kind of boot image that wouldn't have to be updated.
Yep.
And then only have the regular kernel package update way of doing things and use that. And so in this specific use case, it didn't work. In a different use case, it could be actually useful, and as long as you have anyway the specific kernel which we'd like to get rid of at some point anyway.
Thank you.
Thank you. All right, so I think you all once again for your comments. A few final points. We still have a few minutes left. A few final points I would like to bring to the table. It's basically some random ideas. We have our own, in Mobian, our own image build service, which is using Debs and recipes and so on, which is working quite nicely. But if we end up improving hardware support in Debian itself, improving tweaks management in Debian, why not having some Debian-wide image build service, which we could use easily to generate custom images for our devices, but also other devices. If you've seen the developer news email this week, you've noticed that there's a new subdomain of Debian.net, which is meant for the MNT Reform laptop, which is open source hardware based on IMX8M and so on, and provides also pre-built images for this device. So Debian-wide image build service could be useful to those kinds of projects. Another thing which is more mobile related is push notifications. You're all pretty used to having applications on your smartphones notify you as soon as you have a message and so on. And for now, under Linux, there's no standard way for that. Each application has its own implementation of notifications, and there's no central service for push notification. There's Unified Push, which aims to be a solution for that and could fill in this gap. We need first for it to be actually really used widely, applications to take back. But if that happens, maybe having some Debian push notification server would be useful to our users. I don't know, just random thoughts. And also we could maybe have a mobile-friendly Debian installer in the future. For now, on Mobian images, we have installer images which use Calamares, so the same installer as Debian Live, but with a very specific module, which is an upstream module meant for mobile devices. But maybe the Debian installer itself could be made mobile-friendly. And so maybe you can have other comments or suggestions on other parts of the ecosystem that could be improved for mobile devices.
The other thing that comes to mind is testing of all this. So is anybody operating a lab in which we can stick a bunch of devices and make sure that all of this stuff keeps working?
No, that's one of the big pain points for now, is that we have no automated testing at all on mobile devices. There are a few people thinking and experimenting with that, but for now it's basically we rely on the community to do the QA and file bugs when they're needed.
So if I may add the testing part, the post-market OS trying to do some there are people trying to build some CI farm, but it's a little bit harder for mobile phones than for general computers because you don't have usually the dev kits, you have only the phones, so like triggering power and off, you have to like use custom relys and triggers for the buttons. Plus then the bootloader thing, which we discussed, it's like the fast boot isn't very CI friendly, so switching A and B partitions and sometimes behaving weird is happening. So like there is some blog post about building some basic CI farm for phones, but I don't think it's yet deployed and used like on an everyday basis. But there is some work for it, and it will be like at some point, like probably months available.
Thanks for the details.
Here running Android phones in server farms because the whole Android development team, there's an awful lot of phones in racks out there. Now, I don't really know how they're managing that, but there's probably some people here who might have something useful to say about making this work in a useful way. I don't know if it's all just done over ADB. That's how you actually talk to the devices. That might be slightly different from testing new image installs as opposed to just building stuff on phones, I guess, is what's mostly happening, which is easier. On this notification thing, there's two pieces to this, right? There's your user interface notifying you of things, which we do have standards for, and then there's sending things over the network to your device in a push way, which is what you're saying this new thing is. And is the bit which is annoyingly proprietary, often on your existing phones.
Yeah, the thing is, people expect to have some kind of push notification service, which is not managed by the application itself.
Right, and the main reason is because it saves polling power.
Yeah.
Right. Yeah.
That's it, and also because if you have such service, you can have a single user space daemon, for example, running under the user account, which would wake up the phone at periodic intervals to check for notifications and not have like 15 processes competing to get the bandwidth once the phone is woken up. So, yeah. I guess that's it for me. Yeah. So, we've got one final question.
This may be a chance to end on good news. I was wondering, could you speak to what the status is for mobile keyboard input on this stack as far as like software keyboards that people use? It's very important for the form factor.
Right, so yeah, software keyboards are a complicated problem because basically there's no Wayland protocol which is standardized for that kind of things. So basically all existing software keyboard implementation use some of the Wayland protocols which are existing, input method, text input and stuff like that, but they also add their own protocol on top of that, and so pretty much every software keyboard implementation is tied to one specific Wayland compositor right now. So that's a bit of a mess. Hopefully there will be some work to one standard implementation, one standard protocol for software keyboard. But until that happens, we're still left in a less than ideal situation. Thank you all.